Doctor, I would like to welcome you all to this workshop.
Thank you, Anju. Uh, I'll just share my screen. So good afternoon, everyone. Can you see my screen? Just double checking, and can you hear me?
We can hear you.
Brilliant. Thank you. So, good afternoon, welcome everyone. So, title for today's talk is Artificial Intelligence Against Cyber Warfare and Espionage. And the reason why we have this title is because our research title Cloud Intel works with this area and in this area, and tries to protect organizations or aims to protect organizations against such threats. So this is the outline for today's talk. We'll start with a brief overview. Uh, we'll talk about cyber warfare and espionage to build some understanding what it is, the difference between the two, warfare and espionage, and then we'll look at the hermetic viper as a case study for warfare and espionage. And the reason why we are going to look at it is because it's the recent um, weapon that was used against Ukraine, and it was actually designed to actually paralyze the entire critical infrastructure of the country. We'll then look at defense mechanisms, the conventional ones, and how they work and how they can protect, if they can protect against such threats. We're then going to move on to role of artificial intelligence in cyber warfare and espionage. How is it different than the conventional security mechanism? Is it any better? Is it scalable? And how does it perform against new attacks? And then we're going to talk about Cloud Intel as a solution in the context of all these things that we had discussed. The reason why we are using this Hermetic Viper as a case is because we ran it through. Our tool identified it, it caught it in the wild, and it went through series of tests and analysis. And the report, I'm going to share with you the report and what we found and how our tool performed against a novel attack, which was designed for first espionage and then warfare. Okay, let's start. So the remarkable evolution of malware in the past 2 decades has pushed the countries into a very dangerous new realm of cyber warfare and espionage, which revolves around intelligently designed pieces of malicious software that bypass the conventional taxonomies that have defined malware up until now. What we mean by that is, you might have heard or you know that there are different sort of malware like ransomware, banking Trojan, P2P botnets, advanced persistent threads, worms, viruses, all of that. But the modern um, weaponized code or modern malware have diminished these boundaries that define these taxonomies. And now a single piece of malware can be a worm, can be a Trojan, can be a botnet, can be advanced persistent threat, all in one. The latest iteration of such malware have upped the ante by inflicting catastrophic damage on their targets, and that's why they are quite commonly used nowadays in espionage and warfare. The conventional security mechanisms employed by organizations rely on the artifacts from known malware, which involves signatures, fingerprints, heuristics, which are effective, but only for detection and prevention of previously identified malware and some of their variants. This is the reason why an intelligent and self-learning and highly responsive mechanism can replace the conventional tools and techniques. We're going to further explore the weaponized code used in cyber warfare and espionage, and the AI-based security mechanism we have developed that can identify, prevent, and further classify the malware, along with identifying the origins of the attack and how it can be stopped in future if something similar is originated from the same source or from a different source. So, what's warfare and espionage? in the domain of cyber. So cyber warfare, by definition, involves the actions by a nation state or international organization to attack and attempt to damage another nation's computer, information networks, or critical infrastructure through, for example, computer viruses or denial of service attacks. So this is the definition of cyber warfare. Espionage, on the other hand, is a form of cyber attack that steals classified sensitive data or intellectual property to gain advantage over a competitive company or government entity. There's a clear difference, and it needs to be remembered that cyber espionage does not equate to cyber warfare, even though it sounds like one. And in fact, making such a link is completely unjustifiable. Even though it can compromise privacy or classified information, it cannot be considered as an act of war. And mixing both can be extremely dangerous. So, however, espionage has a huge role in warfare, in cyber warfare. So espionage is a key component in warfare. When we talk about cyber espionage, it's really important to mention advanced persistent threats, or what they're commonly known as APTs, that are actually quite pivotal in espionage or in cyber warfare. Um, let's have a look at how they're defined. They're different stages of advanced persistent threats. So stage one, gain access. Stage two, establish a foothold. Stage three, deepen access. Stage four, move laterally. Stage five, look, learn, and remain. So first one is how you infect a system, how you stay in the system, establish a foothold, how you gain persistence, deepen access, how you run in plain sight, and then how you propagate in a network or ascend the hierarchy of a network. And then the last one is to stay there and learn about the infrastructure or the data that's part of that infrastructure. However, until there's an actual attack, doesn't matter how ridiculous it sounds, there's an actual attack or an attempt to damage another nation's computers, information networks, or critical infrastructure through, for example, computer viruses, denial of service attacks, it cannot be considered warfare. The reason why I am kind of fixating on this is because the case we are going to discuss, the Hermetic Viper case we are going to discuss, actually revolves around these areas, and it had different stages, different um, uh, um, images of itself or applications of itself that it deleted or removed when it was traversing through the network. So uh, let's look at the case study. Uh, we acquired two samples of Hermetic Viper. First one through our distributed high interaction honeypot. So we are going to discuss it later when I'm going to talk about Cloud Intel. But just to give you an overview, it's a highly distributed and um, responsive system, and there are different phases or different modules attached with this system. One of the module is our high interaction honeypots, and the reason why we have high interaction honeypots as part of this system is because that we uh, gather artifacts, and our AI models continuously learn and evolve based on this real data. So we caught one of the samples of Hermetic Viper through that high interaction honeypot, and the second one was through our research partner. Okay, so based on the analysis and public reports, initial activity, just to give you an overview, initial activity of this malware that can be partly associated with this attack started in November 2021. Bear in mind that the malware wasn't activated until 23rd of February. By activated, I mean the actual attack didn't start until 23rd of February 2022. Okay, can we call it an advanced persistent threat? That's the question, because generally, and a lot of people might disagree with with this fact, but that APT is there in the system for months and months, sometimes years, gaining access, gaining information, getting data, stealing things. But obviously, this goes back in Hermetic Viper's case, this goes back to 3 months. But we established just in this slide that what are the key stages in advanced persistent threat, and we are going to um, look at that when we are going to discuss Hermetic Viper in detail. So the brief: behavior, technically an APT, worm-like behavior, conventional delivery mechanisms. I'm going to talk about the delivery mechanisms and how it traversed. Stayed hidden for a couple of months. Date time-based automated trigger. Built-in behavior evolves with each iteration. Diversion to avoid detection and anti-forensics technique. Technically in APT, because as I said earlier, the initial activity that can be associated with this attack started in November. Worm-like behavior because it traversed through the network, deleted previous instances, and so on. Conventional delivery mechanisms. Again, it's really important to understand. Doesn't matter how advanced the malware is, how sophisticated it is. Generally, what happens is the delivery mechanism, how it is delivered to your computer or to victim's computer, is quite conventional, and mostly it works. Date time based automated trigger means the system or the malware didn't activate until it hit a specific time, and then it triggered or unpacked itself. Evolved with each iteration. We're going to look at how it evolved, how it created diversion, and how it employed anti-forensics techniques. Planned impact by the attackers. So master boot record and partition corruption, wiping off critical systems data and backup, which means that wiping off everything in critical infrastructures, database, escalating privileges to achieve persistence, anti-forensics, and byte overwritten. Anti-forensics, it's byte overwritten is basically how they employed anti-forensics. The reason why they employed it is because to avoid generation of indicators of compromise that are used once there is an attack to actually avoid similar attacks in future by getting forensics details of the files. Anticipation was paralysis of critical infrastructure, complete paralysis of critical infrastructure. If it had been successful, would have rendered Ukraine completely paralyzed of responding to any physical offenses. So no official record would exist after this. Paralyzed military correspondence, utility supply failure, no counter offensive against any physical offense. So let's look at the analysis. The screenshots you're going to see in this presentation, most of them are from our tool, and some of it I had to remove because of confidentiality, but a lot of it is there and will be useful. So to start with the analysis, this is the sample we caught in the wild. This is the hash SHA-256 hash function for this. If you look at the loader certificate, this is what we got. So locality, Nicosia, organization, America Digital Limited, serial number this, valid from this to April 14th, 2022. So this is a certificate which was generated with the executable that was part of the whole package. How is it relevant? We are going to discuss it in a minute, and it is something that enabled this Viper malware to evade detection. On the right-hand side, we've got top behavioral aspects. It had ZOG, it created service, ran as a service, escalated privileges, modified registry, and used file operations. The tools we used our own in-house developed tool, Cloud Intel. It's developed in University of Gloucestershire's Malware Research Lab, and for referencing, we use Gidra as well. So delivery and weaponization. We talked about the delivery, and I said that it's regardless of how sophisticated a malware is, the delivery mechanisms are quite conventional. So delivery mechanism employed by this Viper malware relied on spear phishing, which is an email-based attack targeted towards a specific individual or an organization or department within an organization, which masquerades to be from a trusted source. So it enabled credential stealing, and it actually employed multiple techniques, as you can see in the diagram on the right hand side. So there were hundreds of emails, if not thousands, sent to different people with different titles, and with different roles. And each of that email has either a malicious PDF with a very important title attached with it, or a RAR attachment, or a malicious link. These cleverly designed emails. The reason behind that is if either of them work, they were in the system, and they only needed one of that to work for one organization. Email used as a delivery mechanism has a malicious RAR. In some instances, it was just PDF or a link. Receiving after receiving the email downloads and unzip, extracts the contents of file which contain malicious PDF or a document. So the infection. So infection is different, and there's a misconception. Infection is different from delivery. Okay, infection means it refers to the process in which a malware exploits a particular or multiple vulnerabilities in a computer network or become part of the system or infected. It's also known as the entry point for that malware. The sample we got, it had a timestamp, which was 28th of December 2021. Based on the analysis and public reports, initial activity that can be partly associated with this attack started in November. Obviously, the timestamp is different than that. And the reason for that is the timestamp is for the executable, the main executable of the malware. The initial activity that can be associated with it started in November 2021 because the spear phishing emails or the exploitations they started in November. Okay, malicious server message block protocol activity was used against one of the critical organization in Ukraine on 23rd of December, which led to credential theft. This was followed by installation of web shell uh, on January 16th, 2022, which paved way for the Viper to be deployed on February 23rd. So this timestamp is for the Viper malware itself, which wasn't deployed until 23rd of February. Up until then, there were different instances of that, but each of those instances had a very specific functionality. And once that functionality was achieved, it deleted itself from the system while overwriting the bytes to avoid detection or avoid post invasion analysis. The analysis showed the actual timestamp to be 28th of December, which highlights the premeditation of this attack. So the infection. We talked about one of the vulnerabilities that were exploited, the service message block. The clever thing this malware did was multi-factor infection mechanism. It used multiple vulnerabilities, not just one vulnerability. We know of at least 3 vulnerabilities that it tried to exploit. So the document received via email, when executed, downloads a template, a macro-based template on victim's computer from a remote location. As highlighted in the image, as you can see, the screen grab from our analysis, which contains obfuscated code to evade analysis. So what happens if you look at this, there is this macro-based source available on this remote location in the target node. However, in the background, it drops and executes a script. It then used Tomcat exploit to access PowerShell along with SQL Server exploit for vulnerability CVE 2021-1636. Okay. The infection, continuing with that, as part of the infection process and to make this attack catastrophic for the victim, Hermetic Viper first check the VSS volume shadow copy status and disable it if it was enabled. This ensured, the reason behind that was, before it did anything, it looked at the system, the infected machine, whether the VSS was volume shadow copy service was enabled or not. Obviously, this sort of mechanism in conventional this kind of operation in conventional security mechanisms, they do not raise any red flags because it's just checking for the service. And if it was enabled, it disabled it. This service does is it ensures that there's a backup of your data. In the operating system ensures that there is backup for data in case you lose something. So disabling it ensures that if the malware or if the file is deleting everything, there is no backup. Okay, so the idea behind disabling this service was to ensure that there is no backup left for the critical systems and infrastructure. As you can see on the right hand side, an offset service name, VSS, and then open service, and then closed service handle. The second thing is propagation. The way in which this discussion is flowing, or the way in which the reason why we are going in this flow is because this is how our tool works. It starts with the delivery mechanisms and move forward with the infection and then propagation. Infection, how it exploited multiple vulnerabilities or single vulnerability, and then move towards propagation, that how it actually literally propagated, proliferated in the network or ascended the hierarchy in a network, and then how it achieved persistence, stayed in the system forever or whenever it wanted to, and then what covert mechanisms it used to stay hidden in the system. And that's how we are going to talk about uh, this case. So propagation refers to how a malware spreads itself literally or ascending the hierarchy of a network. The propagation behavior of Hermetic Viper is aligned with the definition of a worm, computer worm, which is primarily designed to self-replicate in order to infect other computers in infrastructure while remaining active on infected computers. Um, the very clever thing that was employed by this malware was a separate executable that had a very specific operation or very specific purpose, and that was to actually propagate. Okay, it used modular approach, as we talked about, that the initial activity just exploited SMB, service message block vulnerability, and then the second one it opened PowerShell, and then the others came in. So each of that file, the DLL that did that job, had only that functionality, and once that functionality was achieved, it deleted itself. And then up until when the actual Viper malware arrived in the system, or on the systems on the 23rd of February. And the same applies to the wizard kind of tool or DLL that had one purpose only, and that was propagation. Okay, so another intelligent technique used by such malware to avoid detection is changing their state as they proliferate, which includes but not limited to structural changes, behavioral changes, code changes. And the reason why they do that is to avoid detection. And how do they avoid detection by these changes? Is because even the conventional mechanisms that are designed based on known malware, that detect known malware, they can generate signatures. And as soon as there's a signature out for a malware and its variants, it can identify that file as malicious. So continuous evolution and changing while they proliferate and while they propagate in the system ensures that there is no single signature that can be linked to that file. Hence, the database that will have those signatures won't be able to match with the current version of the file. Okay, so Hermetic Viper is equipped with a specialized tool termed as Hermetic Wizard, which embeds the behavior of a worm and enables this malware to replicate and spread across the network. If you remember at the start of the presentation, I talked about the thin lines that are diminishing, that are disappearing, that define malware taxonomies. And I said a single malware can be a worm, it can be a P2P botnet, it can be a ransomware, it can be a Trojan, and that's when I said that Hermetic Viper is that kind of malware. And Hermetic Viper itself is not it's not a worm, but the DLLs it embeds, or the tools that embeds that help propagate this malware, has these behaviors. Okay, it's a Viper disk wiping malware. That's the definition of this. But some of these functionalities the DLL or the modules that it holds has worm-like features or behavior. So the DLL-based wizard exports the following functions: DLL install, DLL register server, DLL unregister server, and they're quite clear to understand what it's planning to achieve: to install itself, to register as a server, and to unregister as a server. When it has these functionalities, it can achieve that level of persistence and propagation. Continuing with propagation, it has a DLL name, wizard.dll, comprised of 3 encrypted PE resources. Every DLL or every executable have multiple resources. Resources that are there for specific functionalities or to achieve a specific functionalities. This specific DLL comprised of 3 encrypted PE resources. Number 1, hermetic wiper sample itself to actually install the wiper malware on the infected machines. Romance.dll that uses SMB to literally propagate in a network. exec_32.dll that uses WMI, Windows Management Instrumentation, to literally propagate in a network. And that hermetic wizard is executed via this command, which was again embedded in the string resources in that DLL. So if you look at the middle 2 points, romance.dll and exec_32.dll, it refers back to what I initially said, that it uses multiple vulnerabilities. Both of these, romance.dll uses SMB to literally propagate a network, and exec32 uses WMI to propagate a network. Both have the same functionalities. The reason is to avoid single point failure. If romance.dll fails, then exec_32 comes into play and is able to propagate the malware. So in order to propagate, it scans for IP addresses of local computers with the help of Windows functions listed below. So it exported the following functions in the DLL to achieve its objective of propagation. So get IP, net table, net server, EDAM, DNS get cache data table, and so on. So Windows functions for local IP address identification of the ranges, the domain ranges, and the IP addresses in order to propagate in the network once it has opened ports and created power and web shell. Now, the third one is persistence. It infected the machine. Number 2, it successfully propagated, and it's propagating. The third one is to achieve persistence in the infected machines, how it can stay there whenever till it executes itself or till it executes the attack. So another criterion that enables a malware to achieve success is the idea of persistence. Okay, it means that the malware is able to permanently run in the system regardless of system's changing state, which means, but it's not limited to, updating the system or system restart or upgrading of the system, right? Whatever happens, the malware stays in the system. How it achieved, how this specific malware achieved that was to run as a service. So malware generally achieve persistent by running as a service in infected computers. Same strategy was employed by this particular malware. So for persistence, it actually had 4 resources or 4 drivers in its resource section, okay, which were deployed based on victim's operating system version. So there were 4 different four different drivers that were part of the resource section, and those 4 different drivers actually were for specific operating systems. So the list of drivers are designed for both 32 and 64-bit architecture and align with Windows XP 7, 8, 10, and 11, and they are compressed using LZS algorithm. That's a very key point. There are 2 key points here. Number 1 is that in order to achieve maximum proliferation or propagation, it actually employed drivers or infected drivers from multiple ranges for 32 and 64-bit systems, for Windows operating systems ranging from XP till Windows 11. And the second key point is the algorithm it used. And our system was able to identify it as a flag and we cross-reference it with different conventional antiviruses and security tools, IDS and IPS, and none of them were able to identify it as a red flag, was this LZSS algorithm. LZSS algorithm is it's something that was previously used by Microsoft for encryption. So this also elaborates why one of the dependencies was LZ32.dll in the list of DLLs found in our analysis. If you look at the top diagram, importing LZ32.dll as a dependency, uh, this was highlighted and identified as a flag by our AI-based tool. So it's an old format for compression previously used by Microsoft, which is no longer used. And when the analysis found that LZ32DLL was one of the dependencies, it immediately raised the flag. And to run the driver as a service, Hermetic Viper escalated privileges to first delete the existing registry key and then run the driver without raising any red flags. So if you look at the bottom diagram, you can see that the escalation of privileges to run the file as a driver and to run as a service and to continue running as a service. And when it runs as a service, even when the system starts, the service, and when the system restarts, the service restarts with the system without raising any red flag. And since it's a driver, driver has a higher level of privileges because they sit between kernel and the operating system. Now, the fourth thing is the covert operation, which is very interesting in this case, similar to the other things that this malware employed. It is pivotal for the success of any malware attack that it stays hidden, especially before the attack, and cover its track after the attack to avoid future detection. Okay, even after a successful attack, if the analysts are able to identify the behavioral aspects of the malware, it'll enable them to illustrate indicators of compromise of that particular malware, right? So one of the techniques, as I mentioned earlier, was the anti-forensic technique employed by this malware, which actually used bytes overwriting after every iteration to avoid any sort of indicators of compromise to be generated after um, uh, after the attack. So indicators of compromise can be used to identify infected computers or networks and quite quickly stop the spread of a malware and its variants. It can be employed by it can become part of the database in antiviruses. It can become part of the AI based or machine learning based algorithms that can learn from that and then move on. But um, the systems that are based on just indicators of compromise or learn from only indicators of compromise have very limited functionality. Still, they were able to, Hermetic Viper was able to remove that just to cross that off the list. So as discussed earlier, evidence from malware artifacts suggests that the cyber attack on Ukraine's critical infrastructure had been planned months ago and it wasn't executed until just 24 hours before the actual physical invasion started. This means that prior to the virtual attack, malware needed to stay hidden while propagating in different aspects of critical infrastructure. So it achieved this by a two-factor approach. Achieved the covert aspect or property by using it or by employing a two-factor approach, diversion and evolution. So let's talk about the diversion. It used a decoy ransomware, hermetic with the name of hermetic ransom, to divert analysts from actual malware and its objectives. As it propagated in the different parts of the critical infrastructure, it wiped itself from the infected disk by overwriting the payloads files with random bytes. So this is, as I said earlier, is an anti-forensic technique to avoid post-infection analysis and obviously disables any chance of generating indicators of compromise. In addition to these techniques, it also deleted existing registry key to run the drop driver as a service. So the drop driver that we talked about earlier became part of the system, became part of the critical infrastructure without raising any flag because it deleted the registry key. Okay, so hermetic ransom was initially reported on 24th of February. On the actual day of physical attack, it was deployed to divert from the background operations of the Viper. And regardless of how trivial the functionality of the ransomware was. Ransomware itself is it's quite a name. It has earned a name for itself, and in a very um, volatile environment that was going on in, during that time. Uh, um, excuse me. Uh, During that time, having a ransomware in your system triggered really panicked, really panicked behavior, or really panicked response from the authorities. So attackers left a few strings. We're going to talk about the ransomware in a minute. Attackers left a few strings in the binary, apparently for the U.S. president. So if you look at the this string in the screenshot, you can see projects 403 for Biden, White House, etc., and so on. These strings were left as a message, but despite their representation, I mean, if you look at it, it might look like they are commands or they're doing something, but despite their representation, they had no operational significance. As error 403 might know translate to forbidden, it's not that hard to decrypt these strings. As mentioned, Hermetic Ransom was deployed as a diversion and therefore wasn't the lead entity in this scenario. In our analysis, our Cloud Intel has a module with a sandbox environment where we can do dynamic analysis. It didn't encrypt most of the files present in the system. It did encrypt some of the files, but most of the files that were available and that are designed to be vulnerable and can be encrypted, they weren't encrypted. However, following ransom node did come forward in the analysis. As you can see, I've just redacted the special ID for the computer. Apart from that, everything is there. This is the ransom node from Hermetic Ransom that came forward in our analysis. So, summarizing the digital anatomy of Hermetic Viper. This is how it started from the top. Spear phishing email facilitates credential stealing, downloads and runs MSI, loader embedded in Microsoft installer, which enables HTML smuggling technique or malicious loader JavaScript, and then it downloaded two-phase executable. One was the decoy ransomware, Hermetic Ransom, which had a ransomware image and a scary ransomware image and a ransomware node. Opens on the main screen when attack is executed, which triggers a response that everything is encrypted and obviously a panic in system administrators. But the actual functionality runs in the background, which executes malicious DLL and open communications with command and control. These are the operational details of this malware. So starting from the infection, multiple vulnerabilities were targeted: malicious SMB activity, Tomcat exploit, Exchange server compromise, MS SQL server vulnerability, CVE 2021-1636. Key operations involved privilege escalation, PowerShell, Web Shell, Windows operating system and architecture, checking VSS and disabling it, leading to persistence and propagation. For propagation, it used Hermetic Viper, Hermetic Wizard, and persistence was achieved via drop-in compressed payload using multiple drivers and running driver as a service. It then achieved covert operation through Hermetic Ransom and deleting existing service registry key. The plan outcome, as discussed earlier: master boot record and partition corruption, anti-forensics approach to evade incidents response. So, which leads us to key question: how did it get through? Because if you uh, look at these vulnerabilities, not all of them were 0 days. There were some patches available for these vulnerabilities. Identifying privilege escalation is not that tricky, and even conventional security mechanisms can do it. If PowerShell is not activated and a tool or a service is creating PowerShell or initiating PowerShell, rule-based security mechanisms can identify it. Yes, checking operating system version architecture is a normal software thing, and checking VSS and disabling it again might not raise a red flag, but others other key operations can raise red flags. Um, so how did it get through? Multiple vulnerabilities exploitation, avoiding single point failure. So in some of the systems, some of the system had some patched tools, but they were missing one or two patches that enabled it to actually infect. Evolving wide traversing, so it completely changed its structure and behavior, as we talked about it, that every module that it had a different behavior. So once that behavior was achieved, once that target was achieved, it deleted itself and it evolved into something else. Persistence through privilege escalation, creating diversion, uh, targeted multiple heterogeneous systems, avoided identification as a potentially unwanted program. How did it avoid the identification as a potentially unwanted program? Uh, what does this prove? It proves that it could have been stopped at multiple points, but going back to the initial point of how did it avoid identification as a potential unwanted program, um, it's all of us are here computer users, and we have come across antiviruses and their messages in our personal computers. We've seen that it says that we have antivirus identified a malware, a virus, or a potentially unwanted program. A potentially unwanted program is identified by by the antivirus as something which doesn't have a proper certificate. It doesn't mean that the file itself is malicious, or its signature or its fingerprint is part of the malicious database uh, that is powering up the antivirus. It only means in most of the cases that there is no proper certificate associated or publishing certificate associated with that uh, specific file. So going back to what we initially talked about in the initial uh, part of the analysis, is this loader certificate. This certificate was stolen, and when the antivirus comes across this specific thing in the resource section of the portable executable or the exe file, uh, and it says it's a certificate, this ensures that it's not a potentially unwanted program. It's coming from a known entity. It shows the validity. It shows the serial number, which can be cross-referenced. Right. This is how it avoided the potentially unwanted being a potentially unwanted program. And because there are two main categories that the antivirus work on, is one is the malware and different type of malware, and the other one is potentially unwanted program. It avoided being identified as a malware because uh, obviously it wasn't part of that database, and avoided being part of the potentially unwanted program category by having a legitimate certificate associated with it. Okay, so let's talk about the defense mechanisms. The current conventional security mechanisms that you can find in the market, even the uh, really paid ones and enterprise ones, are based on signature heuristics, rules and policies, and some form of manual analysis. I know I've oversimplified it, but it's a fair summary. The good that can come out of it is they're good for known malware and most of their variants. Can classify, differentiate between a malware and a potentially unwanted program, can detect, prevent, delete, quarantine, block known malware, threats, and web pages, links, web links, etc. Which is quite good and works well up until 60%. So only works for known malware. The most popular antiviruses can only detect up to 60% of known malware. I've tested it. I'll show you the results. Can consume up to 50 to 60% CPU resources while running in scan mode. And I know you all share the pain when I say how much our antiviruses consume our CPU resources. have highest level of privileges in the system, which are generally known as God level privileges, because their operations are based on that. So, which also means that if that antivirus is compromised, if there is a vulnerability in that antivirus, anyone exploiting that, any malware exploiting that, can have God level privileges on the system. The ugly, whether it's ugly or not, that's for you to decide. I'll just list what it is. So every security software has proprietary database of unique malware signatures, which they take pride in. And that's one of their selling points, that our database is unique, is rich, and it's based on, and it's frequently updated or updated 10 times a day and whatnot. Uh, Lack in intelligence sharing amongst the security company, security organizations, among security community, lack of technique sharing amongst the community, lack of evolving technique sharing amongst the community. The reason why I'm calling it ugly is because uh, security organizations operate under these points and a lot more that are quite binding, a lot more legislations and all that. Attackers don't abide by any rules. They don't need licenses. They don't need to follow any legislations. Hence, it's quite easy from their perspective to do operations that they wish to do, which brings us to the role of artificial intelligence in cyber warfare and espionage. So now we have the context. Now we know how the espionage and warfare works, the role of espionage in the overall cyber warfare. Let's talk about the role of AI in that domain. So it's different than conventional mechanisms. Uh, Automation is kind of similar to conventional mechanisms. Highly responsive, again, is quite similar to conventional mechanism. Accuracy is different. It ensures very low false positive, high detection rate, high prevention rate. Vulnerability assessment is another um, key objective, defining rather than assuming anomalies. Personalization, behavior based computational resource consumption. That's where Cloud Intel comes in as a solution. So, problems: lack of behavioral identification, multiple tools requirement for critical infrastructure security, lack of vulnerability assessment, policy and rule-based approach, locally hosted and resource intensive security solutions, lack of responsiveness in prevention, lack of accurate malware detection, and low detection rate. Let me just define some of them briefly. Lack of behavioral identification. What I mean by that, um, every network, every enterprise network, every critical infrastructure network has its own behavior. A lot of security solutions that are, I'm not just talking about antiviruses, I'm talking about intrusion detection systems, intrusion prevention systems. They are based on rule based, they are based on rule, they are based on policies, etc. Obviously, those rules and policies are defined by the network and systems administrators of that particular organization. But something that that bypasses those rules and policies is the actual behavior of that network, because a critical infrastructure might have a behavior, a subtle behavior, a behavior that's hidden, that cannot be defined in a policy or a rule. What happens if you avoid that is it raises the number of false positives. That's one thing. And when it raises the number of false positive, it raises the flags that sit somewhere between red and green, example amber. And a lot of these threats get away because of that. Okay. So again, to define the behavior, let's say we are in a network and there are certain policies associated with the network. Uh, Define or strict policies and rules um, only look based on those limitations that are part of that document or part of that XML file or whatever rule based or document type they're using. Uh, AI based approach, what it does, is it identifies the specific behavior of the traffic that's coming out of single node and in general the overall network and how it evolves, right? So sometimes, I'll give you an example. Sometimes a malware operates differently um, in nighttime as compared to daytime, and it's a lot. It happens a lot in advanced persistent threats that during daytime, when there are more resources in network, there are more monitoring going on in the network, more human element is present. The malware doesn't unpack itself or doesn't perform any operation. As soon as it goes on to the let's say past 6 o'clock, 7 o'clock, or over the weekend, it starts generating traffic and it starts working to achieve its objectives. But sometimes, so if a rule-based approach is used to tackle that, it can tackle. But sometimes I work over the weekend in the same infrastructure, or my colleagues work in the same infrastructure, and our traffic is quite different from our week-based traffic or weekly traffic. So with that in mind, the policy and rule-based approach will raise loads of false positives. Okay, so as a solution, uh, Cloud Intel provides continuous vulnerability assessment. That's first thing to avoid any 0 days being present, and automated update can work independently or alongside other solutions, a full GUI based solution or an API based integration in existing tools. Lightweight to avoid extra burden on the hosting machine, minimal digital footprint, and intelligently scalable presence. Autonomous, self-evolving, and personalized approach. Personalized approach again based on organization's requirement or critical infrastructure's requirement. Highly responsive, highly accurate with intelligent analysis, and high detection rate through pattern classification. How we achieved that? We divided it into three main phases. So phase one, cloud-based intelligent malware detection. Phase 2A is cloud-based network anomaly detection, and 2B, multi-cloud based intelligent network security. Phase 3 is node-to-node recovery model. Let's look at these things. So phase 1 results. I have nothing personal against antiviruses, but this is just a result as part of the pilot study. So these are the top 10 antiviruses we use here in the UK and around the world as well. And the CPU and detection rate of that. So the blue bar represents the detection rate, and the orange one represent the CPU usage, and it's based on um, the files around 200,000 files, 200,000 malware that we had in the repo. So as you can see, Bitdefender consumed more than 50% of CPU resources while detecting less than 50% of the files, or identifying less than 50% of the files as malicious, and so on. Okay, so and as part of the comparison in phase one results, our CPU utilization comparison with the antiviruses and obviously our hosted framework and its real-time detection aspect. What I mean by that is that it's in the scan mode. So antiviruses are in the scan mode, and our model is in the scan mode. The highest level and the number of hours there, it's with each cycle. It ran for around 5 hours, and the antiviruses, they have this CPU utilization, as you can see, up to 35%, and the proposed hosting model maximum consumed 5% of CPU power in the first run, in the first cycle, and then it significantly dropped to less than 1%. And how it achieved that, obviously, as I said earlier, it's cloud based. So the comparison of the cloud activity is also relevant. So let's look at that. So this is the CPU utilization or real-time detection aspect of analysis and classification module. on the host instance in the Amazon cloud. And this interface is from Amazon's CloudWatch. And as you can see, on the left-hand side is the CPU utilization percentage, and the top one is up to 3%. As you can see, in the first cycle, it started from 2%. In the middle, it went up to 2.5%. Probably it was analyzing a difficult file, but then it never went above 2%. And that's if you combine them, if you combine the CPU utilization of the cloud instance and in the local hosting model, even combination doesn't go above 7%, 7.5%, which shows how significantly efficient this solution is. Phase 2A, design and implementation. So as you can see, there are two main elements. When we talk about artificial intelligence, we talk about data. Obviously, nothing is possible without data, and we talked about reporting, we talked about generation of indicators of compromise, but our solution goes beyond just indicators of compromise, and I'm going to show you what it generates as a sample in the next slide, just a brief sample. But this is design implementation is divided into two parts. One is the heuristic threat intelligence. Part of it is similar to conventional detection mechanisms, because obviously you can't ignore the effectiveness. Doesn't matter how inefficient or how limited it is, it does work for some known malware. Okay, so we do employ that, but in a different way. And on the left hand side, it's tactical threat intelligence, which is the network data. Okay, so on the right hand side, we've got clean files repository and malicious file repository to, and we have a very personalized tool that we have developed here as part of our first phase, which does static analysis, and it generates clean and malicious features, which are then used for training and testing purposes, and that equates to half of this phase 2A. The other half is tactical threat intelligence, where we've got clean network traffic and malicious network traffic, which is using to its core artificial neural networks. It then combines the clean tactical analysis repo and malicious tactical repo using unique algorithms or combination of algorithms, and combine the reports of tactical threat intelligence and heuristic threat intelligence. This next slide is just a very limited illustration of what feature sets or labels we use in as part of our reporting mechanisms. Obviously, the hashing, the fingerprinting is there. How many resources are there? Hash of each resource. We also employ wireless total results as something that can be used as because we want to avoid any extra processing. If somebody else has already analyzed that file as malicious, we don't need to put it through a thorough process. If it's already identified, it's already in our system. It's already in our database. So we don't have to run it through the system again. We just identify it as malicious. Okay, and so on. Okay. Phase 2B, I can't go into detail of phase 2B because it's confidential. I'm working with our research partner. But what I can tell you is it's multi-cloud based intelligent network security, which works on the scalability and scales the cloud-based interface quite seamlessly across multiple clouds, be it Google, Microsoft Azure, or AWS. Phase 3 is node-to-node recovery. So inspired by serverless architecture for heterogeneous critical networks, avoid single point failure powered by cloud-based intelligent detection engine and multi-cloud hosting. So to start with the first point, inspired by serverless architecture, it ensures that there is no single point failure, because it's a single node can be a server. A single node in critical infrastructure can be a server, even if there is there's a denial of service from the server, denial of service from the external cloud model, which is supporting this architecture, a single node can become the server using our unique algorithms and identify the rest of the nodes as their clients and start protecting them and isolate any infected machine or any infected node in the network. And it's specifically designed for heterogeneous critical networks, which also means that this mobile phone, if it's part of the critical infrastructure network, it can actually work as a server to detect or to identify malicious activity in the network. As I said, it avoids single point failure, powered by a cloud-based intelligent detection engine, which I talked about earlier. So let's look at some recent results. I've just results are quite detailed, but I've just captured the relevant part that we can discuss here, and eliminating any confidential thing. So this is result one, which is again based on our honeypot data and the high interaction honeypots we have as part of the system available. So this is the quite basic report, the limited report, activity threat level critical threat PE malware, which means it's Windows-based malware that we have identified. These are the hashes, and it's category B. The categories are internal to the system. Category B refers to ransomware. Family, which family does this malware belongs to? Belongs to WannaCry. And the last but the most important one is the vulnerability it's targeting. So the tool itself is so efficient, it works so quickly that in very limited time, and I'm saying split of a second, it can identify the specific vulnerability, not just the hashes, not just the level of threat, not just the family it belongs to or the category it belongs to, but the vulnerability that specific malware is targeting, which is the key element. Because if the vulnerability is not patched in the system, our system can identify that there are, it first can part of the one of the modules responsibility is to ensure that there are no known vulnerabilities, right? If there is, and this specific malware is targeting that, obviously it's going to block it and then work on any node which is vulnerable against this vulnerability. Result number two is a network-based anomaly detection. So activity threat level critical threat network anomaly. Type of anomaly is port, and number of port is 34545 and 34546. And the prediction, threat prediction, because the in this result, uh, we don't have the portable executable or the exe file or the DLL. We just have the traffic that is part of the traffic that's generated, and immediately it generates this and creates a prediction that this traffic can be associated with P2P botnet based on our training, based on our model. Okay. Number three, result number three, I've redacted the fingerprints because this malware is this file is just a personalized file. So activity threat level critical threat PE mal hash, the specific category C P2P botnet, family unknown because it cannot be associated with any known malware out there, because as I said, it's kind of homegrown. Vulnerability it exploits is this specific vulnerability, CVE 2022, very latest one, 24541. So what it proves is that even though it's not a known malware, it's a really new vulnerability. And another important thing that I haven't shown here is that it has, and I cannot show here, is the it comprises of a legitimate license. So it cannot be classified as potentially unwanted program. It cannot be classified as a known malware. Still, our tool was able to identify it, and not just identify it in split of a second. It was able to identify the specific vulnerability this malware was targeting. Okay, so to summarize, uh, Cloud Intel effectiveness in warfare and espionage. So the package, Cloud Intel's package is behavioral anomaly detection, continuous evolution and personalization through behavior identification and incorporation of honeypot, high interaction honeypot data, which is distributed across multiple regions. Vulnerability assessment, continuous vulnerability assessment by the system, and thorough reporting comprising of tactical and heuristical analysis. So um, this talk started with an overview of cyber warfare and espionage. We then discussed the Hermetic Viper as a case study on cyber warfare and espionage and how it attacked Ukrainian critical infrastructure and organizations associated with that infrastructure. An evaluation of current and conventional security mechanisms was presented as well, and we then focused on the role of AI in the ecosystem of cyber warfare and espionage. Using that as a context, we talked about the operational details and effectiveness of our tool developed in the malware analysis lab, malware research lab in University of Gloucestershire, Cloud Intel. Thank you very much for listening, and I'll open the floor for any questions that you might have. Thank you.
Thank you, Dr. Kubrai. That was really nice. It was really good to know about all these malware. I myself have a few questions, if you don't mind.
Yep.
When you're okay, the first to begin with, this Hermetic Viper, is this one of the new ones? Has it never been happened that something acting like which cannot be detected? Was this something new that was attacked on Ukraine, or is it something that happens time to time?
Well, I mean, the behavior is not new. It's common behavior in APTs and APTs that are used in cyber warfare. The way they used it was yes, it was new. The way they exploit the vulnerability was new. How they divided into multiple modules, it was new, even though the technique is not new, but how they employed it is new. The vulnerability, obviously, they exploited. One of the things that was very clever about this malware was the multiple vulnerabilities it targeted. It didn't rely on just one vulnerability because from their perspective, they had a lot at stake. So they used multiple, at least 4 or 5 vulnerabilities, just to ensure that if one system has one vulnerability patched, it might have other unpatched to proliferate across critical network. Along with that, the malware, the main malware itself, they were playing it really safe and clever. That the main malware, Hermetic Viper, wasn't deployed until February 23rd. Before that, small DLLs modules that had limited functionalities were deployed. So even if it was caught, it was not caught before, but even if it was caught during that process, it wouldn't have revealed anything about the Hermetic Viper, which was then deployed. So they were paving the way. They were just paving the way for the main malware to be deployed and executed on just a day before, just hours before the physical invasion, the war started.
That's interesting. So, since this is something, the new technique that they have used, the way they have employed it, it has become a good case study. When it was employed, was there it was attacked, but are we just learning from it and trying to find a solution like AI based, because the existing ones are not working on it? So, has it paved a way to study and get a solution for something like this if it happens again?
That's a very good question. It has paved a way to understand that the conventional mechanisms are not good enough and were never good enough. But still, quite limited companies are using any AI-based solution, because most of them, and even the most of the critical infrastructures, are using rule-based and policy-based approaches. And what it triggers is this discussion that why are these security solutions so limited, and why are they not evolving? Because it's a multi-billion dollar industry, and why the innovation is not being injected into this industry, because we are talking about, and there are some researchers that use machine learning techniques to identify malware, AI-based approaches, deep neural networks. I'm just listing all these just to say how different people are working on it. But as a solution, as a whole solution, there are very limited approaches being used, which benefits the industry. And that's when I talked about the ugly part of this industry, that it's proprietary based, money based, and as the malware authors or the people who are attacking, they don't play by the rules, so they don't have to abide by the rules. They can do whatever they want, and because they're already doing something really illegal. So just
Absolutely.
uh,
For them, there's no rule, so it's
yeah,
easy for them to attack. For something like your company, which is a CloudNet, am I right in saying that
cloud
they're
intel.
working on something
Yeah.
like a cloud-based AI system? Is there any existing one which is already there in place or working on it, or is this
Well,
something new, unique?
how we are doing it, and we want to call it unique, but there are AI-based approaches being used. Dark Trace is one of the main organizations who are doing very well. We have some quite unique techniques that we will want to highlight, and that are quite different from Dark Trace. But I think Dark Trace is the only organization, and proudly UK based, that are doing something like this. It's quite different from conventional security mechanisms.
Okay, that's brilliant. If you can take the Q&A from the chat here, I think the first question was from me as well. This one, while you were on the slide for the VSS, I just had a small question on that. You said the backup will be disabled because by
Yeah.
disabling VSS, it will be disabled. I was wondering, because the existing data should be backed up somewhere. Would this malware actually deleting the existing backup on some other? I'm sure it's not on one system, it should be somewhere else as well.
Yeah, very good question. So that uh, the infection ensures that the stored data, the persistent data, is deleted, is wiped off. VSS ensures the runtime data. VSS ensures the data that it can bring back to life when it was last in its from its last state. So the malware was ensuring. So the first thing it was doing is to ensure that no runtime image is saved or can be restored. For the persistent data, it was already working to delete that anyway. So the VSS was an additional layer of maliciousness that it was employing.
Ah, that's intelligent, isn't it? As a malware, that's good job done.
Yeah.
The next question is for Amanda. In your opinion, what would be the benefit to the attackers to leave strings in the binary in this circumstance?
Political statement.
Making a mark?
Making a mark, political statement that look where we are, what we have done. You can't stop us. This is a message for you. If you look at the if you look at these strings, it shares it talks about luggage packup or baggage gatherings, White House dot baggage gatherings, White House dot lookup, primary election process, all that, which hints that, I mean, we can do all that, we can interfere in all that, and this is a proof. So political statement.
It's a
I
mocking
just,
tone in binary, isn't it?
Yeah.
Sorry,
I
go ahead.
only meant, sorry, with that is that, I guess, I mean, sandworm wouldn't have been identified, I guess, maybe not quite as quickly or as well, if they hadn't been leaving the names, and so why they would still be.
So
Sorry, it's like
these
4 o'clock, 5 o'clock in the morning, and on the west coast of Canada.
it's
Wonderful. We welcome you here, Amanda. That's brilliant.
It's very early. It's just I just wonder why people are still doing that, or at least putting it with the AI. Thank you.
Yeah, no, very good question. The idea of an APT or cyber warfare is not just to actually damage; it's actually to make that statement as well. And I didn't mention other countries in this because, again, didn't want to make it political. But many countries know that their arch nemesis or whatever, they have some sort of cyber advantage over them. And these things they know based on that sort of statements that are made like this. Having said that, these strings were not part of the initial files or DLLs. They were not identified, and they cannot be identified via conventional mechanisms. They can be identified once everything is done, once they've executed everything, and then they leave behind this, that this is what we have done, and it was not a fluke. This is something that we planned and we executed. So it was not something that comes before anything, it comes after everything.
I guess I know that in Canada, we had in January of this year, the foreign ministry in I know you're in the UK, but the foreign ministry was breached, but nothing kind of came of it.
Mm.
It was just identified that it was Russian based, and that was it. And it just kind of seemed like almost like testing the firewalls of what our Canadian government can do, which is actually very little as a result as I was identified. So it just kind of seemed like they didn't even pretend with that one. Like that one was very clear. Like there was no question. We were like, oh, okay, and it was right after Canada had announced the intention of, cybercrime threat accommodations sort of thing. So, okay. So thank you very much. I will.
No problem. Another important point I want to make here is that this is not the screenshot of these strings. This is not something which comes from an official channel. I've only seen these strings from just one source, the internet. No official documentation of this malware has these strings. So we identified it. No other official channel has released this thing. And the other element is it's the reason why a lot of times they do find this in analysis. Obviously, they've got resources to find such strings, but obviously it's embarrassing for for a developed country with billions of dollars in cyber security budget to have this as a string that look where we are or what have we done.
Yeah.
So
okay.
yeah.
Thank you so much.
Thank you, Amanda. The next question, if you'd like to take up from Simon Cross. Great overview, very technically. Do you have any repositories for analysis?
I do some, and I'll soon release after looking at some of the confidential stuff. But I do have some for analysis.
Brilliant. One is from Dr. Rukma. Hi, thanks, Pabali. It was very informative. Can you please state what network features the system used and why they were chose?
Yeah, it's I can't. Good to see you, Maruk, that you're here. I can't actually specifically mention what network features we use, but I can have a private conversation with you next time you are here in the office. That what features we use or we talked about.
Brilliant. I think a link has been shared by Simon about 2021 top routinely exploited vulnerabilities published by CISA. So that's good information.
Yeah, and the second question Mara asked was my other question. In case of unknown family, how can criticalness? Yeah, so the identification of family is, to be honest, is not that important. the main thing is what kind of malware, because the family defines whether it belongs to it's a WannaCry variant, it's a Zeus variant, it's a Mirai botnet variant, or what other family it belongs to. Or because in the screenshot there was no family identification, and the reason for that is because it was kind of a homegrown thing. But the main thing is what vulnerability it exploit. Can we identify or can we generate indicators of compromise from it that can be used and can be made available for other security organizations to incorporate in their databases. So the level of threat is decided based on the vulnerabilities exploiting and the type of malware and what it does. So opening specific ports, identifying specific vulnerabilities and how it can capitalize on that.
Brilliant. I hope that answers my question. Also, just one last curiosity that I had. There are no more questions on the Q&A session, but I had just had the curiosity to ask you. In the last slide, I think towards the end, you showed some result of your CloudNet. When you identified those things, was these malwares intentionally put by the system to do a test, or were they the real malwares?
So
or
no,
you knew what they were, and you just
so
checked.
the first two results, one from WannaCry and one from P2P Botnet, they were actually identified via our honeypot. So we have honeypots running that capture and high interaction honeypots, which expose a lot of services and really hard for the malware authors or for the attackers to identify that they are actually honeypots, not real systems. And they are running these our instances of Cloud Intel. So what they do is when they are attacked, they perform these tests on the analysis and generate multiple indicators of compromise, not the conventional one, the indicators that we use. And we also perform automated attack based on some new vulnerabilities on those systems. And the last one, where it says family unknown, that was an attack that was performed by us on our system to identify whether it's responding to the to unknown malware and to unknown signatures, and whether it's classifying it as a potentially unwanted program or a malware.
Thank you so much. I have thoroughly enjoyed this workshop and the talk given by you. And so I'm sure by our audiences, they have really enjoyed it. I thank you on behalf of the whole audience. There's some clapping for you.
Thank you very much.
It was lovely to have you here. And thank you all the delegates to come and enjoy this talk with. I have somebody writing something, but thank you so much.
No problem at all. I just want to share before we start this talk, we talked about the cyber symposium we're having, and I want to just share that with you. Just a second. Oh, it's not allowing me to to add that. We have a cyber symposium on 7th of July in C11 Berkeley, and what I can do is share my screen to just quickly show.
That would be nice.
So it's a really big event, and a lot of security organizations are going to be part of this, and a lot of unique projects will be discussed. Security-based projects will be discussed. So if any of your viewers want to be part of it, it's a free event. It's face-to-face. So yeah.
Oh, brilliant. I think Zainab has just shared the Eventbrite link on the chat. And yeah, thank you so much. I think we'll stop the session now, and thank you everyone for coming.
Thank you.
Thank you.
Take care.